and delegates present here. My name is Vikas Kumar and I am doing Masters from Malaviya National Institute of Technology, Jaipur, Rajasthan, India on topic renewable energy. The work I would like to present today is support vector regression based thermal performance assessment of photovoltaic panel. Outlines. I will follow the standard outline. First I will give brief introduction, after that motivation, objective, background, methodology, validation, result, conclusion and references. Introduction. Photovoltaic solar panel is obtained by converting sunlight into electricity using technology based on photoelectric effect. The total amount of solar energy received on Earth is vastly more than the world's current and anticipated energy requirement. From this figure, we can see that there are lots of losses like shading, dusting, spectral losses, reflection, array mismatch, thermal losses, etc. But the energy loss due to high temperature is one of the major losses. The electricity generated from PV panel can be used for different lighting purpose, battery charging, telecommunications, power household appliances. As we all know that intensified research is going on around the globe to increase the renewable energy source like solar energy. This chart shows that there is a continuous increase in electricity generation from solar cell, and this chart is taken from Central Electricity Authority of India website. Misconception among the masses that the stronger the sunlight, the greater the generation power of solar panel, but we don't focus on the operating temperature of the solar panel, as the operating temperature has a direct impact on the conversion efficiency. From this graph we can see this, that as the operating temperature of cell is increasing, the conversion efficiency is decreasing. For better understanding, we can see the IV characteristics at different temperature. As the temperature of the cell is increasing, the IV graph is shifting towards the left. And ideal condition, the dotted line is at standard condition, that is 25 degrees Celsius, 1000 watt per meter square irradiance and 1.5 am. After that, as the temperature of cell is increasing, the curve is shifting towards left. In 7th century BC, solar energy was used for burning fire, and in 1839 the photovoltaic effect was discovered, and in 1954 first PV cell invented, and in 1981 the first solar power airplane is built. Objective. My objective for work was to introduce machine learning with solar PV panel system to predict the power generation and panel temperature under different conditions throughout the year, and compare the performance of solar panel with fin and without fin. Methodology. To proceed with my work, the technique was to collect historical weather data of 5 years for Jaipur location from India's meteorological department. The SVR model was trained using weather data to predict solar radiations. Then simulation was carried out on 40-watt polycrystalline silicon PV module of dimension 660 mm and 430 mm at two different cases, one with fin case and another without fin case, under different operating conditions like wind velocity, ambient temperature and at different irradiance level. Then data was collected to train the SVR second model. The SVR2 model PV panel predict the solar PV panel average temperature. In that, the PV panel average surface temperature was collected from CFD simulations, and these data is trained using SVR, and after that it predict the panel surface temperature. Solar radiation prediction. These are the depth detail of solar radiation predictions. The first data was collected from IMD, that was from 2004 to 2008. In that data we have date, time, humidity, ambient temperature, wind velocity, wind direction, and irradiance. After that, these data are used to train the SVR, and after that, grid search CV method was used to optimize the parameter and kernels. In from grid search CV, we found that SVR radial basic functions was performing better than polynomial and linear. And in SVR radial functions, the mean absolute error and RMSE error was MA is 0.29 calories per centimeter square and RMSE value was 0.45 calories per centimeter square. Computational domain, as I already discussed, these are the computational domain among their material properties and assumptions considered for the study. Fin with the base are attached to back side of the panel after the back sheet, and assumptions was the heat loss from the side of PV panel and radiation losses are neglected in present study. Thermal contact between the fin base and PV panel back sheet is assumed to be the perfect. Numerical simulations. These are the boundary conditions considered for computing numerical simulations. The wind velocity was considered 0.5 meter per second to 10 meter per second, and ambient temperature was 303 Kelvin to 321 Kelvin, and irradiance was 200 watt per meter square, 2000 watt per meter square, and these values for parameter are chosen based on climatic condition of Jaipur, which also was the basis of selection of the range of intensity of solar radiations, which extended in the range from 200 watt per meter square to 1000 watt per meter square. PV panel temperature predictions. These are the depth detail of solar PV panel temperature predictions. The data from numerical simulations was collected and used to train SVR, and in this research CV method was used and RPF model was performing well with MAE error was in no fin case 0.12 Kelvin and with fin 0.09 Kelvin. RMSE values was 0.16 Kelvin for no fin case and 0.11 Kelvin with fin case. Validation. The trained SVR model for panel surface temperature prediction was tested for validation at 4 different random cases. As we can see that SVR model panel temperature model has maximum error is only 0.05%, and in case 1 as irradiance was 423 watt per meter square, wind velocity was selected as 0.6 meter per second and ambient temperature is 301 as we have predicted 327.24 Kelvin, and from CFD simulations we got 327.08, and so percentage error was 0.04, and for with fin case as we have predicted 315.59 Kelvin and CFD simulation 315.42 and error was 0.05%, and similarly so on. Slide number 13, 14, 15. I have tried to capture the effect of using fins in reduction of PV panel surface temperature with respect to varying I irradiance, velocity and temperature. The effect of in this figure we can see the effect of ambient temperature on PV panel at varying different wind velocity for constant irradiance. Using the fin, the average panel temperature dropped by 23 Kelvin when wind velocity was 0.5 meter per second and irradiance level 832 watt per meter square. And in this figure, the effect of irradiance on the PV panel temperature at varying ambient temperature for constant wind velocity at ambient temperature 321 Kelvin, I at 832 watt per meter square, the average panel temperature dropped by 13 Kelvin in the comparison of the panel without fins. In this graph, we can see the effect of wind velocity on the PV panel temperature at varying ambient temperature for constant irradiance. The rapid drop up to 20 Kelvin when ambient temperature was 301 Kelvin and wind velocity is varied from 0.5 meter per second to 3 meter per second. These two graphs shows the year-round performance of with fin and no fin cases. This graph is for 0.2 meter per second and this graph is for 10 meter per second. The fin significantly reduced the temperature, but the effect were more evident in the month ranging from March to June, which is accounted up to 5.7%. And there is a declining trend in the pennon temperature during the August. It is due to the rainy seasonal climate. Conclusion. The major conclusion I could derive from the work are: the temperature reduction of PV panel with fin was remarkably enhanced when compared to PV panel temperature without fins. An ASVR based prediction system was utilized in forecasting the mean surface temperature of PV panel under different ambient conditions, including temperature and wind conditions. It is observed that there is a sharp decline in the PV panel surface temperature at wind speed ranging from 0.1 meter per second to 3 meter per second. After that, there is not that much difference in panel temperature as compared to with fin or without fin. So at higher wind speed, even though the temperature values are seen to fall, but the rate of decrease was significantly reduced. The all-time increasing requirement for more reliable and accurate weather forecast. The temperature prediction system pushes the field to widen up their spaces for further investigations. These are the references. Thank you for your attention.